The physics of golf. The swing. Newton's three laws can easily be applied to the swing of golf. Newton's first law: an object at rest stays at rest, and an object in motion stays in motion until an outside force acts upon it. Both the club and the ball remain at rest until an outside force acts on them. In this case, the ball remains in place until the club strikes it, and the club remains in place until the player swings it. Newton's second law: force equals mass times acceleration. The golf club has a high force and a high mass, so the golf ball will result in a high acceleration since the golf ball has a much smaller mass. This allows the golf club to remain on its path while the golf ball is thrust forward at a high acceleration. If the golf ball had a larger mass than the golf club, then when the player swung the club towards the ball would stop the motion of the club and probably break the club. Newton's third law: action-reaction. Every action has an opposite and equal reaction. The ball applies an equal force backwards onto the club, but because the club has a larger mass, the force is not as noticeable. Thus the ball thrusts forward and the club has no noticeable backward effect. Club ball physics. Club velocity is the key to long shots. The twisting motion of the swing creates torque on the club. This torque creates rotation, and when it comes into contact with something, in this case the ball, the force is transferred to the ball. Since all club heads are about the same weight, the key to hitting the ball far is to swing the club at a faster velocity. The faster the club head is going at the bottom of the swing, the more kinetic energy is being transferred from the club to the ball. This is because kinetic energy equals mass times velocity squared. So the more velocity, the more kinetic energy. Following through. The reason golf players follow through on their swing is directly related to impulse. Impulse is the contact part of the collision and the only way momentum can be transferred. By following through, the player maximizes the amount of time the club spends in contact with the ball, which increases the impulse. The larger the impulse, the larger the momentum. Thus, the farther the ball will travel. When the club impacts the ball, the force actually deforms and flattens the ball. Kinetic energy is transferred and stored as the ball regains its original shape. Here's a video of how the ball looks when it's deformed. Flight of the ball. Wind speed and direction have a large effect on how the ball will travel since the mass is so small. An experienced player knows that if there is a headwind, a wind going against the path of the ball, then the player should shoot the ball lower to avoid some of that wind. If there is a tailwind, a wind going in the direction of the ball, then the player should shoot the ball high and allow the wind to carry the ball a farther distance towards the hole. Small adjustments in the angle of the club and the way the player is facing have a large impact on the flight of the ball, because minor adjustments cause large differences in the way the small ball is affected by the large forces in the sky. The ball. The ball is designed with small dimples that allow it to fly farther because the dimples scoop the air back towards the rear end of the ball. This creates more air pressure behind the ball and results in a farther distance traveled. If the ball did not have these dimples, then it would travel a much shorter distance because it would not have that extra force of air pressure behind it. Also, if the dimples are too deep or too shallow, then the ball will not travel as far because the depth will not be able to thrust the air backwards as easily and will not be able to create the same amount of pressure behind the ball. Physicists and engineers have done many tests and research to develop the best dimpled ball that produces the maximum amount of air pressure behind it, which results in the longest distance traveled. Here's a video explaining why dimples are so important.
As I was watching TV a few weeks back, a commercial caught my eye. It was for a new type of golf ball that was dimpleless. It claimed that this would make the ball fly further and straighter and would improve my game tenfold. As a golfer whose game could certainly use some improvement, I was intrigued. Could a dimpleless golf ball really help? Right away, though, I was skeptical. Skeptical because every golf ball I've ever used or even seen has had dimples on it. This could not just be a mistake, and as it turns out, it isn't. As the game of golf evolved from a bunch of guys in kilts whacking stones with sticks, it was noticed along the way that a ball with nicks and dents in it would seemingly travel further. The aerodynamics involved as to why this is becomes a bit too complicated for the purposes of this video, but the basics are as follows. The dimples on a golf ball create turbulence within the air around it. This turbulence allows it to grip the air better, and because of this, the spin on the golf ball becomes an important factor as to how the ball will fly. For instance, as the ball spins backwards through the air, if it's straight, the ball will continue to rise, traveling a further distance. The trade-off, if the ball is spinning right or left, would be more likely to hook or slice and go out of play. In theory, then, a dimpleless ball would have the advantage of flying straighter. So if you have a wicked slice, you may want to consider it. However, with the lack of turbulence, the ball would also not fly nearly as far.
Spin of the ball. Bernoulli's principle. Bernoulli's principle explains why the ball flies either slightly left or slightly right when it is hit. The ball will fly towards the left if the club is slightly angled left when it comes in contact with the ball. This causes the ball to spin to the left, which creates a low pressure zone on the left side of the ball. This causes the ball to be sucked towards the low pressure zone, resulting in the ball slowly drifting leftward. Bernoulli's principle also explains backspin. In this case, the low pressure zone is created on top of the ball, which causes the ball to be sucked upward. This causes the ball to go much higher, but not as far. Backspin causes the ball to gain loft and stay in the air longer, and allows the ball to drop quicker at the end of the flight. Technology in golf. Advances in technology allows physicists to accurately analyze the swing of a player and the effects that air resistance and other factors have on the flight of the ball. This research allows engineers to develop better clubs and balls that maximize the ability of the player and minimize the actual skill required to be successful at golf. For this reason, the United States Golf Association was created to limit the technology used by professionals. Conclusion. Although golf seems like a simple and boring sport, it is actually a very interesting and complex game when one considers all the physics behind the easy action of simply hitting a ball with a club. Next time you see Tiger Woods playing a golf game on television, think about all the different forces and physics behind each and every aspect of the game. Here's my works cited. Hope you guys see golf in a new way now. Thanks.